Hey guys, so I want to make sure that you're super prepared for your quiz, which is on Friday. So it's going to cover two things. It's going to cover graphing inverses. Okay, that's what we did on Tuesday. And then it's going to cover solving for inverses, which we did Wednesday, and we're going to do again today on Thursday. So I was afraid that since we've covered solving for 2 days, that you guys would forget how to graph. So we're going to do 3 quick examples just to kind of get you thinking about it. There is not homework assigned with this. This is really just more for you to be prepared for your quiz. Okay, so first one, you'll notice this is a straight line. So the linear parent function is y equals x. Remember, that's not an equation for this line. That's the equation for the parent function. So when you have one like this, all that you really need to do is pick out several points. Okay, obviously we want them to be whole numbers, so don't try to pick that one. Okay, I see one right here. I see one right here. And I'm going to take each of those 5 points and I'm going to put them here in my table. So this is -6, -8. Okay, this is -4, -4. This is -2, 0. This is 0, 4. And this is 2, 8. Now notice this one is already graphed for you. It's even labeled here for you. This is F. So remember that for F inverse, I'm just switching the order of those points. So for example, this first point becomes -8, -6. Then I would graph it. -8, -6 right there. -4, -4. Notice that point is exactly the same. That's okay. It's going to be this exact same point right here. Okay, then -2, 0 is 0, -2, graphed right here. Okay, 0, 4 becomes 4, 0, which would be right here. And then 2, 8 would become 8, 2. Then if I go to 8, 2, that would be right here. Draw your line. There is your inverse. This is F to the -1. Now remember that your graph should always be a reflection across the line y equals x. So that's your perfect diagonal through the graph. So if I draw this in, hopefully a little bit carefully, okay, you can see that these graphs match on either side. That's symmetric, okay? All right, let's go down to the next one. Okay, this time we have y equals x minus 5 squared plus 2. First thing you should notice is that your parent graph is x squared because you have a squared there. That means that it's going to be a U shape. Okay? From there, we would look for our vertex. So notice that we have a -5 and a +2. The -5 is going to switch to a +5. So I would put 5, 2 right here. Remember, the vertex always goes in the middle. Then from there, I would take out my calculator and I would type in the full equation. So y equals, clear out what's in there, -x minus 5 squared plus 2. Once I get that typed in, I can look at the graph just to kind of confirm that it is where I think it is. You'll notice that this U actually opens down. We learned last week that it opens down because of this negative sign in the front. Okay, second table. I'm going to scroll down to 5, 2. Put it right in the middle of my graph here, and then I'm going to record the 2 points above it and the 2 points below it. So the point right above it is 4, 1. The point right above that is 3, -2. Okay, then I'm going to record both of these points down here, 6, 1, and 7, -2. If I go through and I graph each of those points, I'm going to have the original graph that I saw right here on my picture. So 3, -2 is right here. 4, 1 is right here. 5, 2 is right here. 6, 1 is right here. 7, -2 is right here. There's my U. Now, this is the first one that we've actually done that opens down. But remember, the process is exactly the same. You're going to switch the x and y coordinates and then regraph. So -2, 3 would be right there. 4, 1 becomes 1, 4. 1, 4 is right here. 5, 2 becomes 2, 5, which is right here. Okay, and then 6, 1 becomes 1, 6. And -2, 7, 1, 6, negative 2, 7. Then once you graph it, you're going to have your picture like that. Okay, once again, I'm going to draw in my diagonal here. Okay, this is just to check your work. Okay, and you can see that if I were to take my paper and fold along that line, just like we talked about last week, okay, you can see that my green one would end up right on top of my blue one. And anytime that happens, that means good job, you did it right. Okay, last one. Notice that on this one you have kind of a crazy graph, but you should recognize that that squiggle like that is an x cubed graph. Now, we haven't done one of these yet so far, so just kind of pay attention. We have our graph. We're going to pick some whole number points. So I see a whole number point 1 here, here. Looks like we have one here, here. And then we'll just pretend like that's one, even though it's a little bit off, so that we have 5 points. So this is negative 3, 0, negative 2, 2, 0, negative 1, 2, 3. This one is 1, 1, 2, 3, 4, 1, negative 4. And this last one is 2, 0. So I'm going to take those 5 points. I'm going to reverse them in my chart, just like we did on the other examples, even though it's kind of a funny shape. And then we're going to switch them around. So this is going to be 0, negative 3. 0, negative 3. Boom, right here. Okay, then negative 2, 2 is now 2, negative 2. So 1, 2, negative 2. Next one is going to be negative 3, 0. So that would be 1, 2, 3, 0 right there. Next one would be negative 4, 1. 1, 2, 3, 4, 1. And then last one, 0, 2, would become 2, 0, which would be somewhere. Oh, I wrote it in the same order. Duh. 0, 2. Sorry. So 0, 2 would be right here. And then you would basically want to take those points and try to connect them in a squiggly thing that would look similar. So I'm going to just go like this. You would go here, here, here. Okay, now, is it perfect? No. Okay, that's not the point. The point is that you would just do your best. Okay, then when I draw in this point right here, this line through my diagonal, okay, you should see that your graph at least almost lines up. Now, this one was very hard, okay, but if you follow that same process, you should be able to mostly do it. Okay, then notice if I take my paper and I kind of look at it like this, you should be able to see that it matches on both sides. You have kind of like this heart right here, and then you have kind of like a heart going the other way. Okay, but the point is that they match, and so if it's symmetric, you know you did it right. Okay, what you should expect to see on your quiz tomorrow as far as graphing, there is not one this crazy, but you will see a line and you will see a curve. Okay? So make sure that you're ready for your quiz tomorrow, and that you also know how to solve, which is what we covered in class today and then again yesterday. Okay?